Hey everyone! Welcome back to Emmy's Calc class. Today we are learning the power series. Here's a general formula. So C sub n is the coefficients of every term in the series. And then x is the independent variable. And lastly, you will need to know that the negative a is the center of convergence for the series. These are things you need to know when dealing with a power series. First off is the radius of convergence, written as r. This is the radius of the center of the series where the series converges. Next is the interval of convergence, which is the absolute value of x minus a less than r. This is the set of all x values where a power series converges. Last, you need to know the limit, written as L. When L is greater than 1, it always diverges. When L is 1, it's inconclusive. But when L is less than 1, it is absolute convergence. Let's do an example together. We will find the radius of convergence r and the interval of convergence for this power series. So, to start off, you need to find the ratio test. As a reminder, the ratio test is L is equal to the limit as n approaches infinity of the absolute value of a sub n plus 1 all over a sub n. So yeah, let's look at this power series and you'll find that this is our a sub n. Now we are going to write it in terms of a sub n plus 1. So we are taking x minus 2 to the nth power plus 1 all over n plus 1, which we can write as just n plus 2, times 3 to the nth power plus 1. We need to divide this by a sub n, but we can do that by just multiplying it by the reciprocal of a sub n. So this is going to be n plus 1 times 3 to the power of n all over x minus 2 to the power of n. Now look at this. We need to simplify it. So to simplify it, I'm just going to group together the like terms. So the first grouping of the like terms is the x minus 2 to the nth power terms. So we can group it together like that. The next group of terms is the 3 to the power of n terms. And lastly, now we just have these n plus 1 over n plus 2 terms. We can write like that. Now this is a lot easier to simplify. So we can first take x minus 2 to the n plus 1 power and just simply split them up like this. And then we write it all over x minus 2 to the power of n. Now we can see that those actually cancel out. So we're left with 1 times x minus 2 to the power of 1, which is just x minus 2. Don't forget the absolute value, of course. Moving on to simplify these 3 to the n power terms, we can do the same thing where we split up the 3 to the n power plus 1 into 2 different terms. And look at that, now they cancel out, leaving us with just 1 over 3. Now, for this last term, we're actually going to keep it as is. We're not going to simplify it yet because we're going to find the limit of this in the next step. So yeah, like I said, we're going to find the limit as n approaches infinity. We can just write this as absolute value of x minus 2 over 3 now, and then keep the n plus 1 over n plus 2 terms separate, like that. And now first we're gonna find the limit for this term first, and we are gonna take the dominating coefficients, which is just the n's, and that simplifies to just 1. So now we just have to find the limit of absolute value of x minus 2 over 3. And remember what I said earlier, if the limit is less than 1, it is absolute convergence. So now we're going to set this as less than 1. To get rid of this denominator, we're going to multiply both sides by 3 so that it cancels out. And we are left with the absolute value of x minus 2 is less than 3. And now look at that. The 3 is our radius of convergence. But wait, there's more. We need to find the interval of convergence now. So to do that, we're going to split up this inequality because it's an absolute value. We're going to set one side to positive 3 and the other side to negative 3. So let's solve for x. We'll get x is equal to 5, and for the other one, we'll get x is equal to negative 1. Now, this is our interval. Negative 1 is less than x, which is less than 5. Now that we have found our interval, we need to check our endpoints. So how do we do this? We are going to plug in the endpoints back into our original power series. So here it is. Again, we are going to plug in negative 1 into the series and 5. Let's start with plugging in negative 1. So we need to increment the index by 1 and substitute x with negative 1. And we get negative 3 to the n power all over n plus 1 times 3 to the n power. Now we're actually going to take the 3 out. So we'll have negative 1 to the n power times 3 to the n power over n plus 1 times 3n. And we did this because now look at that. The 3 n's cancel out. We are left with negative 1 to the n power over n plus 1. We need to now test this for convergence, and we can see that this is an alternating series, so we use the alternating series test. So let's check if it passed the test. It is positive. That's the first check it passed. Now if we look at the denominator, we can tell that this is decreasing because n is growing. Since n is growing, that also means the limit as n approaches infinity is actually 0, and that passes the last check of the alternating series test, which means this converges. So now we verified that 1 is included in our interval of convergence, but now we need to test for 5. Again, increment the index by 1, plug in 5. We get 3 to the power of n over n plus 1 times 3n. And look at that, the 3 n's already cancel out, leaving us with 1 over n plus 1. And again, we take the dominating coefficients, which is just 1 over n, and oh my god, it's a harmonic series. So that means it diverges. Now we know that the 5 is not included in our interval of convergence, so we are left with this final answer. Our interval of convergence is -1, 5, where the -1 is included but the 5 is not, and our radius of convergence is 3. Yay, we did it! I hope this video on power series helped you, and if it did, drop a like. Thank you!